DNS enumeration. DNS is a distributed database responsible for translating user-friendly domain names into IP addresses. It's one of the most critical systems on the Internet. This is facilitated by a hierarchical structure that is divided into several zones, starting with the top-level root zone. Due to the wealth of information contained within DNS, it is often a lucrative target for active information gathering. Let's demonstrate this by using the host command to find the IP address of megacorp1.com. By default, the host command searches for an A record, but we can also query other fields, such as MX or TXT records, by specifying the record type in our query using the -T option. In this case, we first ran the host command to fetch only megacorp1.com MX records, which returned 4 different mail server records. Each server has a different priority, and the server with the lowest priority number will be used first to forward mail addressed to the megacorp1.com domain. We then ran the host command again to retrieve only the megacorp1.com TXT records, which returned 2 entries. Now that we have collected some initial data from the megacorp1.com domain, we can continue to use additional DNS queries to discover more host names and IP addresses belonging to the same domain. For example, we know that the domain has a web server with the host name www.megacorp1.com. Now, let's determine if megacorp1.com has a server with the host name I don't exist. We'll observe the difference between the query outputs. Since we now understand how to search for valid host names, we can automate our efforts. Having learned the basics of DNS enumeration, we can develop DNS brute forcing techniques to speed up our research. By using a word list containing common host names, we can attempt to guess DNS records and check the response for valid host names. In the examples so far, we used forward lookups, which request the IP address of a host name to query both a valid and an invalid host name. If host successfully resolves a name to an IP, this could be an indication of a functional server. We can automate the forward DNS lookup of common host names using the host command in a bash one-liner. First, let's build a list of possible host names. Next, we can use a bash one-liner to attempt to resolve each host name. Using this simplified word list, we discovered entries for www, mail, and router. The host names FTP, OWA, and proxy, however, were not found. With the exception of the www record, our DNS forward brute force enumeration revealed a set of scattered IP addresses in the same approximate range. If the DNS administrator of megacorp1.com configured PTR records for the domain, we could scan the approximate range with reverse lookups to request the host name for each IP. Let's use a loop to scan IP addresses 200 through 254. We will filter out invalid results by showing only entries that do not contain "not found." We have successfully managed to resolve a number of IP addresses to valid hosts using reverse DNS lookups. If we were performing an assessment, we could further extrapolate these results and might scan for mail to, router, etc., and reverse lookup positive results. These types of scans are often cyclical. We expand our search based on any information we receive at every round. Now that we have developed our foundational DNS enumeration skills, let's explore how we can automate the process using a few applications. There are several tools in Kali Linux that can automate DNS enumeration. Two notable examples are DNS Recon and DNS Enum. DNS Recon is an advanced DNS enumeration script written in Python. Let's run DNS Recon against megacorp1.com using the -d option to specify a domain name and -t to specify the type of enumeration to perform, in this case, a standard scan. Based on the output, we have managed to perform a successful DNS scan on the main record types against the megacorp1.com domain. Let's try to brute force additional host names using the file we created previously for forward lookups. To perform our brute force attempt, we will use the -d option to specify a domain name, -D to specify a file name containing potential subdomain strings, and -t to specify the type of enumeration to perform, in this case BRT for brute force. Our brute force attempt has finished, and we have managed to resolve a few host names. DNS Enum is another popular DNS enumeration tool that can be used to further automate DNS enumeration of the megacorp1.com domain. We can pass the tool a few options, but for the sake of this example, we'll only pass the target domain parameter. We have now discovered several previously unknown hosts as a result of our extensive DNS enumeration. As mentioned in the beginning of this topic, information gathering has a cyclic pattern, so we'll need to perform all the other passive and active enumeration tasks on this new subset of hosts to disclose any new potential details. The enumeration tools covered are practical and straightforward, and we should familiarize ourselves with each before continuing. Having covered Kali tools, let's explore what kind of DNS enumeration we can perform from a Windows perspective. NSLOOKUP is the primary Windows tool for DNS enumeration. Once connected on the Windows 11 client, we can run a simple query to resolve the A record for the mail.megacorp2.com host. We queried the default DNS server to resolve the IP address of mail.megacorp2.com. The DNS server then answered with the IP. Similarly to the Linux host command, NSLOOKUP can perform more granular queries. For instance, we can query a given DNS about a TXT record that belongs to a specific host. In this example, we are specifically querying the DNS server for any TXT record related to the info.megacorp2.com host. The NSLOOKUP utility is as versatile as the Linux host command, and the queries can also be further automated through PowerShell or batch scripting.